groups that we're going to deal with. Up there is the alkane. It's saturated, he just says RH. R can be any one of the methyl ethyl propyls that we talked about, butyls. Alkene, double bond. There's the alkyne with the triple bond. Notice he gives different structures with names. We got to the alcohol and ether, and alkyl halide sort of fits in there, but I said we weren't going to treat that as a separate functional group. We're just going to treat the halogens as substituents. So when we do it as a functional group, and this is sort of arbitrary, but notice if he does this thing where he puts a bromo there, he calls it bromohexane. It's the exact name we would use, but you could also call it 1, 2, 3, 4, 5, 6 hexyl bromide, hexanyl bromide. But that's naming it as the alkyl, as the halogen or the halide. And by the way, these are what? The famous halogenated hydrocarbons that are supposedly, well, not supposedly, they are destroying the ozone layer. Okay, when they talk about halogenated hydrocarbons, it just means you have one of the more common one is the one with fluorine, because we use a lot of different fluorine compounds because they're relatively inert. But they are not inert enough that when they get up into the upper atmosphere, they won't react with the ozone layer to destroy it. Okay? So the ethers and the alcohols are the next two functional groups we talked about. And I said the easiest thing to think about there is you're doing an oxidation reaction. So if I take the 3-carbon chain, I can either make an alcohol, depending on the reagents I use, or I can make this thing, where you have a single bond between carbon on each side of the oxygen. Actually, it's sort of a bent structure. But this would be the ether structure. This, where you have the oxygen attached to a single bond to the hydrogen, is the alcohol. We usually don't put a dash here. Okay? So this one, for instance, would be one propanol, or propane 1-ol, if you want to do it that way. This would be shorter carbon chain with the OXY, longer carbon chain. In the common system, you'd call it methyl ethyl ether. And similarly, this would be propyl alcohol. Sometimes they say N for normal, which means it's only N. So, moving right along, one of the things I want to talk about here. We oxidized, we made ethers and alcohols. Now, whenever you have ethers and alcohols, if you have enough carbons, the first member of the series, you can't make an ether out of that because you don't have enough carbons. So you can only make an alcohol, but this is called methanol. I have this thing, we did the joke about this already, ethyl alcohol. Ethanol is the IUPAC name. And we can say this is C2H6O. 1, 2, 3, 4, 5, 6, O. But also, this one is methoxymethane. Both of them have the same formula. One's ether, the other's an alcohol. These are pairs of molecules that represent functional isomerism. And as I go through the rest of this, I'll be lumping them or grouping them in pairs of functional isomers. Okay. What else can I do with it? There's not too many reactions you do with this. Alcohols, you do tons of reactions. This is an important chemical in modern synthetic organic chemistry. They start with different alcohols and make different things. The other thing I tossed in here as an alcohol phenol, because notice at the bottom of this table here, he puts it down as a separate functional group. Back. There we go. And by the way, we're not going to deal with all these functional groups we have in the table here. Most of them, but not all of them. But way down here at the bottom here, he lists phenols as a class of functional groups. Notice that AROH. Again, in organic chemistry, you see a lot of things like this. AR stands for aromatic. Phenol is the basic one, it's more complicated. So far as we're concerned, it means it has a benzene. Up here, does he have something like alkyl halide? This part means it has alkanes, alkenes, alkynes. It has some sort of double bonded, alternating double bond structure like this, conjugated double bond, fancy words they use. It doesn't have that structure. They're all, they may have double bonds in the parts of it. This would be an here's where the alkane came from. It's a carbon chain, or it could be a saturated carbon ring. Now, one of the things I wanted to mention here, that we've already covered this, but people sometimes don't notice it. And by now you should know that's benzene. This is cyclohexane. How do you, besides that, what else do you have to have in here to distinguish between this molecule and this molecule? Well, you see the A and E, and it's a cyclic structure. You know you have to have 12 hydrogens. These are already carbons, that's what I said. But for the saturated ones, you have to put in the extra bonds to indicate that you have the bonds to hydrogen like that. So I want to mention that, but people don't always notice that. If they leave this out, they're okay, but they're not. And one year I made a joke. And I said, what's that? And nobody said anything. I said, that's Superman's emblem, right? So somebody got together and put in a Superman shirt. Anyhow, that does stand for saturated, but they don't do that anymore. They did that 50 years ago. Okay, so we're working with functional groups. And I wanted to do another step in the oxidation sequence. And I have to do this. I'm going to work with alcohols. And I'm going to introduce some new terminology with alcohols. R can be almost anything. This is what is called a primary alcohol because it has two hydrogens on the carbon with the OH. This one only has one hydrogen on the OH carbon. These could be methyl groups, ethyl groups, they could be benzene rings, they could be all sorts of things. They usually say alkyl or real. That's the terminology I just showed a minute ago with the aromatic. But this is called a secondary alcohol. And these are just R's, meaning they're not hydrogens. They could all be methyls, for instance, or something more complex. But this is called a tertiary alcohol. I guess they use 3-degree, but the word is tertiary. And I want to oxidize these. And I don't want to oxidize it too strongly. Use a somewhat stronger oxidizing agent. By the way, when you take something like one of these organic compounds and set it on fire, that's a strong oxidation. You get carbon dioxide and water. I never expect to see that for an answer in this class. Last year we did combustion analysis. We got that as an answer, but I'm not going to oxidize things that strongly. But if I oxidize this thing, what I do is form a double bond. There's still one hydrogen left here. In other words, I pulled out this thing and made a double bond in here. This is called a carbonyl group. And if you look at this structure, CHO, another way of writing it, there's a functional group that's called the aldehyde. So you use a weak oxidizing agent. A primary alcohol converts to an aldehyde. The secondary alcohol, get rid of that. Something like that. No hydrogens on here. This is called a ketone. So if you oxidize a primary alcohol, you're going to get an aldehyde. If you oxidize a secondary alcohol, you get a ketone. What happens here? Nothing. If you use a really strong oxidizing agent, it breaks up into a bunch of different things, who knows what, and you get what all organic chemists like. Tar just means you get a brown residue in the bottom of your flask and you can't do anything. That happens to you when you're doing organic syntheses in the lab. What do? You start over again. Your instructor's hard nosed. He said, oh, you never pay attention to instructions. You get 5 points off for a new sample of starting material, something like that. But basically, you can't oxidize this to anything. But primary alcohol, you can oxidize to an aldehyde. A secondary alcohol gets oxidized to a ketone. Now, when you start naming the aldehydes, and by the way, aldehydes and ketones are functionally isomers again. First of all, this has to be at the end of the carbon chain. So this is automatically the number 1 carbon, and it gets numbered in this direction. Okay. This one, you could number this way or this way, so you number it so that the ketone carbonyl has the lower of the two possible ways of numbering. I'll come back to ketones in a minute, but let me talk about aldehydes now. This.